we have here is a just a standard run-of-the-mill refrigerator that you might find in a house or apartment or mobile home, whatever. This is really just a basic model fridge. It costs about $550 to $650 brand new. I bought this one new in 2007, November 19th, 2007 to be exact. And it's broken down on me once already. So I'm going to talk a little bit about what goes wrong in this type of fridge. This is a Whirlpool. That's who manufactures it, but it's sold under Frigidaire, Kenmore, and a half a dozen private or other smaller labels as well. Regional manufacturers and nameplates, etc., etc. So the two things that I find go wrong with this model fridge, or this style fridge, are pretty easy to replace, very inexpensive, and anyone can do the job in a matter of a few minutes. The first thing that broke in this fridge was the compressor motor start-run relay. That relay is all but guaranteed to fail at some point. In fact, it's probably the number one reason why most of these refrigerators wind up in landfills or in scrapyards. I made a video on how to replace the relay, but in case you haven't really seen that video, I suggest you Google it, because there are some steps that you need to take before you go and replace the relay. But first, how do you diagnose it? Well, for me, I noticed that when the compressor kicked on, it would immediately kick off. I'd hear the relay click, the compressor would start, and then it would shut off. And throughout the duration of the cycle, or the demand cycle, the the evaporator fan behind the freezer box would continue to run, as it's supposed to. Whenever there's demand for the compressor, that fan runs. So, but however, that fan never runs by itself. So if the fan is going and the compressor's not, then you've got a problem. That was my key indicator that something wasn't right. But occasionally, probably like every other cycle, the compressor would successfully start. So I knew there was a problem. I did a quick Google search. Turns out it's a common failure, and it's the relay. But the problem is, if you don't fix the problem quick enough, in other words, if you let it go or you don't notice it, the compressor coils can and often will burn out. At that point, replacing the relay is only going to result in a fried relay. Because what's going to happen is, now that the coils are shorted out, that relay is going to try to energize those coils, and boom, it'll fry itself. So, if your fridge still runs, and it might be acting up a little bit, get that relay ordered. I would recommend powering the fridge down until you get the relay, and find other alternative places to store your food. I should mention that this relay has been replaced. It was done about 3 years ago, maybe 4 years ago. It's been a while, and it's still humming along like it was brand new. So, for that failure, it can be saved, as long as you catch it before the compressor melts. And you can use a multimeter to check your coils on the compressor from the outside, of course, by just checking a couple of terminal points, and that's all outlined. Just Google it. Again, Google checking compressor windings. It's a very easy solution. If the compressor is gone at that point, if you find that you've got shorted or open windings, open meaning they're burnt open, shorted meaning they're melted together, then you've got a pretty easy choice ahead of you. If the compressor's bad, you might as well just replace the fridge. I mean, you can still replace a compressor. Sears will sell you a compressor for about $130. But that doesn't include refrigerant installation, evacuation. So you've got to evacuate the system. You've got to pump it back up again with refrigerant. and most people don't have that equipment. So you'll be hiring a professional with a truck and all that stuff to come in and do it. So moving on, the second most common failure that I've discovered is the defrost timer. The defrost timer is a little device. It's actually powered by a clock motor on cheaper and inexpensive fridges like this one. And it's mounted right above this console, right there. Now this video is being shot after I've replaced the timer, so I can prove to you that it actually worked. Anyway, the timer is responsible for shutting off the compressor and the condenser, or the evaporator fan, and starting up the defrost cycle by energizing a heating element that's mounted to or intertwined with the evaporator. So what it does is every 10 hours on this model, it's every 10 hours, it cuts out the compressor and it heats up the evaporator, which causes all that ice to melt and drip behind the refrigerator down into a little pan which is mounted to the very top of the compressor assembly. After 30 minutes, it kicks back into run mode. And it's driven by a tiny clockwork mechanism, a little electric motor, a little shaded pole motor, which you'll see later in this video. It drives a giant wheel of contacts, and it just, kind of like the timer on your dishwasher or your washing machine, clothes washing machine. Works just the same way, only it runs continuously, it never stops. And over time, those timers can fail. Mine did not fail. I have to be honest with you, I replaced mine out of caution. Because if it does fail, two things can happen. It can get stuck in the defrost cycle, which will cause the defroster to run non-stop, and it will keep the compressor from firing up. So the heater just gets hot. The whole unit eventually will just overheat, and all your food will start melting, and ice cream will get running and all over the just a mess. So that's a bad, very bad scenario. Best case scenario, which is I believe the more common and what I've seen in my friends and family's refrigerators, is that the timer gets stuck in the run position. So the defroster never works. It never does its job. And eventually, all that ice buildup, which can take only a few days, the ice will build up so thick around the evaporator that it will prevent the effective heat exchange or thermal exchange. So the evaporator stays cold, but nothing else does. Eventually, you'll start having, you'll first notice it when your freezer starts to get really warm and stuff doesn't freeze, ice starts melting, then you know you've got something going on. The first thing you want to check before you go crazy buying parts, though, is you want to check the resistance on the defrost coil or the defrost heating element. That's the first thing you want to check. And then you can proceed from there. And odds are, it's either one of two things. It's your thermal cutoff switch, or it's your timer. Actually, it's pretty straightforward. If it was in fact your I lost my train of thought there. No, but truthfully though, if that happens, it's more than likely either your timer or your defroster. If your timer is, oh, that's what I meant to say. If the timer gets stuck in it, yeah, okay, forget it. It's late, guys. It's 11 o'clock. I'm getting tired. But that's pretty much how you can diagnose it. Pretty straightforward. I mean, either the timer's bad or the evaporator heating element is bad. You know. So what I replaced mine with is a modernized timer, similar in design to the ones used in the more expensive refrigerators. and I know that I heard that GE uses one as part of their main board system. But the new timer is it's a $9 part plus shipping. It cost me $26 with shipping. And it's a solid state timer, meaning it has no moving parts. So it'll more than likely outlast the rest of the refrigerator. I mean, the compressor will self-destruct before that thing ever goes. So I've basically prevented one problem from ever happening. And I'm going to have to do the relay again, which is only a $30 part. It takes about 2 minutes to install. Just pop it off, pop the new one back on again. Good to go. But the relay will be another preventative measure, because I know for a fact that it's going to fail again, because it's just the nature of the beast. For some reason, they didn't use a capacitor start motor, which I think would have been a better idea. I think the relay option is a little bit cheaper to manufacture. And maybe their heart was in the right place. Maybe they thought it would be more reliable than a capacitor start. I don't know. But for whatever reason, they decided to use a start coil, which... Now how that... Now that we got a little bit of time, how that works is it energizes both the start and the run coil at the same time. And the compressor has an additional amount of power to start, or to overcome whatever compression it has to overcome to start that cycle. And as soon as the compressor fires up, the run coil shuts off. The start coil shuts off, and the run coil remains on. And typically, when the relay fails, the run coil can shut off, but the start coil will remain, or it'll try to start without the start coil, and it'll start it on the run coil. I might have that backwards. One way or the other, there's not enough horsepower to get that motor started up. And I believe I was right the second time. It energizes only the run coil, but not the start coil. So it overheats the run coil, which causes it to fail if it's left too long. So yeah. Alright, onward and upward. Let's go ahead and replace that timer relay. Defrost timer. What we're going to do is we're going to start, we're going to cut power first. But what we need to do is take down this module here. The timer is actually located up in here. You can actually see it from this hole, where you can actually stick a screwdriver in there and manually cycle it. So I'm going to need a screwdriver, but first I'm going to cut power. I don't want to get zapped. Okay, power's been cut. I'm going to use a screwdriver. I might need to pull up the wiring diagram for this fridge. I'm hoping I don't have to. But as of right now, my groceries are outside in the car, where they're going to be, the cold temperature will be maintained pretty effectively, because it's like 9 degrees outside. So, just unscrewing the cover here. It's pretty simple. It really is a very simple device. It causes many people so much grief unnecessarily. The device we're going to be replacing it with is a higher-end unit that's made by SUPCO. And their claim to fame is their product has no moving parts. So we dropped this cover here. The timer's right there. And this whole thing actually is pulled out. We can actually take the whole thing out. That way I can keep the door closed. Sweet. So here it is. It's driven by this tiny electric motor. It's pretty simple. This is the, it's basically a tiny shaded pole motor is what it really is. And that's all it is. 25th of March 07 is when it was made. Here's the refrigerator temperature control. This is where the light bulb goes. That bulb's never been changed. this is pretty much it. So we need to unscrew it from the other side. So the benefit of having a solid state timer is actually pretty beneficial. Okay, so what it does is it does everything this timer does, but without any moving or mechanical parts, as I mentioned earlier, which reduces the likelihood of failure substantially. It's a great idea. As a matter of fact, a lot of higher-end fridges, the more expensive models, feature a very similar product or similar part. So we're just going to unplug the old timer. Being quite stubborn. There we go. Just plugs right in. And we're going to take the new one. We're going to look up the part number on the old one. It is part number 241621. So what we really need to do is find out what the timer settings are. Okay, looks like it's 10 hours, 30 minutes. Which means that the defrost frequency is 10 hours, just like that. That should be set to 10. And the defrost runtime is 30 minutes. This is set to 35, so we're going to turn that down. So symptoms of, like as I mentioned earlier, symptoms of having a faulty timer can be as simple as your freezer doesn't get cold, or your fridge doesn't get cold enough to... So one of the first things we need to do is determine what the timer settings are on the old one. Luckily, this one has it printed right on the unit. 10-hour interval and a 30-minute runtime. And on here, we just simply set the clock to 10 hours frequency and the runtime or defrost time of 30 minutes. On the bottom, there's a little black button that we can press to manually cycle it from one position to the other. This is good for testing. So, we need to make sure 3412, 3412. Okay, I want to make sure that the pinout is correct. Alright. Now this is supposed to bolt right in, and it should have access to this manual selector switch, so it just goes right there. Pretty straightforward. Just plugs right in. Couldn't be easier. Now, here are the symptoms exactly. If the timer fails, one of two things will happen. If it fails in the defrost position, your compressor will never run, and your defroster will be constantly in the on position, so it could potentially burn out. You could lose your defroster just by burning it clean out. Now there are temperature cutoff switches inside the freezer to prevent that from happening, so it'll run in the defrost mode, but it shouldn't catch fire or anything. But you will have a lot of grocery spoilage, which can be very, very costly. If the timer fails, and this is the most likely position, but if it fails in the off position, as what happened to my parents, their freezer basically just filled up with ice and all their food went bad. At that point, most people just say, okay, the fridge is 5 to 10 years old, I'll just buy a new one. And that's what most people end up doing. Pretty sad, actually. A lot of fridges go into the landfill because of this one little part. Now, was this one really bad? Not at all. This one still worked. It actually still functioned perfectly. So I'm going to keep it for a little while as a spare. But no, it worked fine. There was nothing wrong with it. But it's a ticking time bomb. I mean, this thing is going to go bad. I'm going to come home to, spoiled groceries and rotting meat in the freezer or whatever. And I'm going to be sad because food isn't cheap. It's very expensive. And that's pretty much my final word on that. So this is it installed. Plugs right in. And of course, if you don't have the wiring diagram and you don't have a plug, you're going to have to find out, you know, obviously, what your settings are supposed to be. And you could even, if you're daring enough, you could actually customize them a little bit and maybe do your own thing. Maybe you can change your defroster if you don't need it to run so often. You can change it to run less. Save a little bit of energy. And if that causes your fridge to, you know, freeze up, well, then change it. Couldn't be simpler. I'm gonna plug this back in. Click. But sometimes I like to fix things that aren't broken because, you know, it's fun. It gives me a choice. It gives me a chance to, you know, play with all my tools and make videos. So you're probably wondering, what does this thing cost? So now I know how to do it. What does it cost? Well, that's the good news. To buy all this technology, it cost me, I think it was around $29, including shipping. But the part itself retails for about $9 to $10 a piece. I mean, it's really not an expensive repair. So I just saved myself a future repair bill. Well, not really repair bill, but I saved myself a little bit of headache by doing this now, while the fridge is still in good working condition. And I'm going to buy another relay to replace that one at about the 5 or 6 year mark after the old one was replaced last time. My goal is to not have to buy a new fridge. Ever. I'm going to keep this sucker running as long as I can. Now we plug it in and cross our fingers and hope to die. No, I see no reason why it wouldn't work. The pinout looked to be exactly the same. I think they're pretty much universal. I gotta move it out. Hear that? It's running. So it's now in the cold cycle. It's going to come down to temperature. But the timer's doing its job. So let's go ahead and kick it over. We're going to switch it over to the defrost cycle. We're going to let it sit for about 10 minutes to get the pressure equalized after the compressor shuts down. I'm going to press the little button in there. It says to hold it down for up to a minute. We're going to get the compressor to shut off. I think I hear the defroster coil running right now. That's impossible. Maybe not. Come on. Set up to a minute. It's been a minute. 30. That's 30 seconds. Alright, this one. There it goes. Now it's in defrost. What we want to see is, we want to hear this coil heating up, or at least see it glowing. So I'm going to kill the lights. Once we know that the coil is glowing, we know it's working. You can actually see it glow. Oops, with the door open. Turns out I was looking for heat in all the wrong places. The coil is down here. And if I hit the lights, you can clearly see it with the camera. You should be able, there it is. See that glow? That is the defroster element right there. So we know it works. We're pretty much good to go. All I got to do is switch it back to compressor mode because this thing has suffered some severe thermal loss from all this playing around I've been doing. So I've got to manually cycle it back to compressor, and it's sat for a good 10 minutes or so. So I'm comfortable that the pressure has been pretty well equalized. So I'm going to just stick my probe in there and start the count now at 54. It's now about a minute. We have to, I think what it does is it speeds up the cycle. So, any second now. You're going to hear that click. I think it clicked off already. That compressor's not running yet. Or maybe not. There it goes. We're back in business. And the button's right there. Pretty easy to get to. So thanks for watching. You now know how to replace a defroster timer in a pretty standard low-end Frigidaire made by Electrolux refrigerator. Stay tuned for more entertaining videos. It's worth mentioning that the part number is not mentioned. The part number on this, either the spec number, the part number, or any other random number, is not listed in the cross-reference chart. The cross-reference chart tells you what the actual timer settings are supposed to be for the interval and duration. But sadly, if mine did not have the information printed on the back of it, I would not have been able to set it up correctly. I would have had to have played the guessing game, basically. So, keep that in mind. 24162, 2124. Now it's not listed at all. So, we also don't know who the original manufacturer was of this part. So, I'm just going to write in ink what the settings are supposed to be, and that way the next person to buy this house, when the fridge is still here, hopefully, knows what it should be if they ever need to replace it again.